Welcome everyone to another interesting DSA problem which is titled as same tree. So let's try to understand what is a problem statement. So you will be given two binary trees. So you can see I have taken three examples, example 1, example 2 and example 3. Each example you will be given two binary trees and a head or root P and Q to the respective binary trees. We have to check whether the two binary trees are having same identical structure or structurally identical. That means it has to be exactly same, node by node, level by level, and the values also should be same. You can see this matched, this matched, this matched, and the structure is also same. So at the first example it is set true, we have to return a true. In the second example you can see the root is fine, but as you go to the left there is a mismatch. Here also there is a mismatch, the values are not same even though it structure wise it's similar. Basically it got inverted, that's not what we want. It has to be exactly same, so in this case it is false. In third example you can see root is fine, but the child left is there, but here there is no left. Here right is not there, but here is right. Even the values are same, the structure right now got different. So in this case also it is false. So we have to return true or false based on the structural identity, or it's called structurally identical. So that's what we have to check. So we can use recursion to solve this problem. Let's minimize the example which we have utilized to create some space. Okay, this is fine. Now let's code it. Class solution, and this is the method inside the class. Define is same tree. So two things are given. P, it's an optional tree node for the first tree, optional tree node, and the Q is given, that's also optional tree node for the second binary tree. And we have to return a boolean expression, true or false, based on verifying whether it's same or not. So what we can see is that we can first have a check if not P and not Q. So both will end either at some particular point. It has to end, both has to end at same time. In that case it's obviously a true. If one ends and other exists, that would if not P or not Q. So it is very important that this condition has to come after this condition, because either one ends, this condition is also satisfied in the first condition, but the first condition and the return statement will prevent unnecessary desired outcomes in this thing. So this basically will ensure that this condition will meet only when one of the node is getting terminated. So in this case it is return false. And another condition is if P dot value not equal to Q dot value. In that case also we have to return false, but we have to go deep and deep. So what we can do is that we can call the recursion return self dot, as we go, let's go to the is same tree, p dot left. So here and q dot left, we are identically going. Here p is also going in this direction, q is also going in this direction. So identically both are moving in this case. Okay, and same thing, and self dot is same tree, p dot right, comma q dot right. So in this state, here p is also going here, q is also going there, so identically going. So whether you go this side or this side, both case identically, it should check all these three conditions. And at some point, if it's like giving you a false, for example, if one gets terminated earlier, if p get terminated earlier, here p get terminated earlier, but p is still here, so in that case also it will return false. Or if there is a value mismatch, just like in the second example, that case also it will return false. So basically this pointers p and q is identically or similar way it is moving and having these three checks, and it will return true if it's structurally identical. So that's what happening here in this case. So what is the time complexity? So the time complexity in this case is order of n, because each node is visited once. That's same logic which we have already seen. Space complexity, so there is a skewed case, just like linked list. In skewed case it would be order of n. If the best case, that is balanced tree, it would be order of log n. I hope you understood this problem, and thank you for listening.